So a skew is an asymmetrical shape or distribution that has additional data points called a tail on one side. For example, this right here is a distribution without a skew, but this right here is a distribution that has a skew. We would call this a right skew because the tail is on the right side. Now, anytime a distribution has some extra data points on one side, you can say that it's skewed. But to be an outlier, that has to meet a special criteria, a special rule to be an outlier. The first rule is called the 1.5 IQR rule. Basically what you do is you take your interquartile range, your IQR, and you multiply it by 1.5. Then you subtract that number from the first quartile and add that number to the third quartile. Anything outside of that range is considered an outlier. Let's practice using it with the data above. So the 1.5 IQR rule for finding outliers goes like this. My boundaries will be if I have Q1, quartile 1, and I subtract 1.5 times the IQR, that's the lower boundary, and the upper boundary is if I have quartile 3 and I add 1.5 times the IQR, get the upper boundary, and anything outside of those boundaries is an outlier. So let's plug in the values here and find my boundaries. So Q1 is 29. Again, I'm going to use this blue data here, the new data after added 16 and 27. So Q1 is 29 minus 1.5, that's given to me as part of the rule, times the IQR, which is 2. So let's see, order of operations tells me I need to do the multiplication first. So 1.5 times 2 is 3. Okay, bring everything else down. And then 29 minus 3 gives me 26. And the upper boundary works just the same way. So Q3 was 31 plus 1.5 times the interquartile range, which was 2. Let's see, 1.5 times 2, I already did that before, that's 3. And then 31 plus 3 gives me an upper boundary of 34. Let's go back to our dot plot and see where these boundaries land. So 26 is right here, okay? And 34 is off the charts, it's up here. So everything inside this boundary, this 1.5 IQR rule, is considered not an outlier. So 27 is not an outlier in this case. However, looking way out here, 16 is an outlier because it's past the boundary of the 1.5 IQR rule. So we could say that 16 is an outlier, but that 27 is not an outlier. It's just causing some skew, just a skew on the data, an asymmetry that's kind of pulling it to one side. Now there's a second rule we can also use, similar to the 1.5 IQR rule, but instead of using IQR, it uses standard deviations. This is called the 2 standard deviation rule. It says that any data point less than the mean minus 2 standard deviations or greater than the mean plus 2 standard deviations is going to be an outlier. So it gives us a boundary just like the 1.5 IQR rule, but instead of doing 1.5 times IQR, it does 2 times the standard deviation. Let's take a look at how that looks with the example above. All right, the 2 standard deviation rule, the 2SD rule. All right, here's how it works. Basically, it's the same kind of thing as before, but instead of using quartiles and IQR, we're going to say we need the mean minus 2 times the standard deviation. That's our bottom. And the top top of this range is going to be the mean plus 2 times the standard deviation. So just like before, we're going to plug in our numbers here. The mean was 29 minus 2 times the standard deviation was 4.33. And so 2 times 4.33 gives us 8.66. Bring down the 29. And then 29 minus 8.66 gives us a lower boundary of 20.34. I'm using a calculator to help me out on this. What about the upper boundary? Well, I'm going to use the same mean, 29 plus 2 times the standard deviation, also the same, 4.33. So 29 plus 2 times 4.33 again is 8.66. That's going to be 37.66. Okay, so looking back at my dot plot, I've got the lower boundary with this 2 standard deviation rule at 20.34. So that's right about here, just a little bit over 20. And over here, I've got my upper bound at 37.66, which is, whoa, it's way off the graph. I'll put it here for now. And so it looks like, just like before, 16 is outside of that boundary, which makes it an outlier. And 27 is inside that boundary, which makes it just a regular part of the data. Maybe you could call it a skew on the data, but not an outlier. So again, 16 is an outlier. And you'll notice that this rule gave me a wider range here of what to call normal versus what to call an outlier. And you'll see that sometimes the rules come up with slightly different answers, but they're both good ways of determining what is kind of a normal part of the data or just a skew, and what is truly an outlier.